Welcome back to the channel and another video. In this video, we will be using combustion analysis data to calculate empirical and molecular formula of a compound. Right? So a typical question would be like this one. So you will get the mass of a compound, 0.25 gram of an organic compound contains carbon, hydrogen, and oxygen. And combustion, it produced 0.595 gram of CO2 and it produced 0.304 gram of water. When this 0.25 gram of organic compound was heated to 200 degrees Celsius at 1 atmosphere, it vaporized and occupied a volume of 131 cm cube. This part of the question is not typical, right? The typical part would have been up here, and then you have to calculate the empirical formula and the molecular formula. But to calculate the molecular formula, you would need the molar mass of the compound. Now from up here, we did not get the molar mass of the compound, right? So somewhere in the question, we will have to use the data provided to calculate the molecular mass of the compound. So the data up here is to calculate the empirical formula. The data provided here is to calculate the molar mass of the compound so that we can work out the molecular formula. So first I'm going to show you how to calculate the empirical formula and then use this information to work out the molecular mass of the compound. Before I start working here, to calculate the empirical formula, this data is from the kinetic theory, right? So we see we get temperature, we have mass, we have pressure, right? And we have volume. So if you have done the kinetic theory using the combined gas law, you know that PV is equal to nRT, right? So this part is kinetic theory. Alright, so I'm going to start now by working the empirical formula of the compound. Alright, so to calculate the empirical formula, we first need to find the mass of carbon and the mass of hydrogen. We are going to use the mass of carbon dioxide to calculate the mass of carbon and the mass of water to calculate the mass of hydrogen. Right? Now there are different ways of calculating the mass of carbon and hydrogen. The way I'm going to do it, right? So CO2 has a molar mass of 44 grams per mole. Right? So now we have one atom of carbon with a mass of 12. And we have 2 atoms of oxygen. The mass number for oxygen is 16. 2 times 16, that is 32. So 12 plus 32, that is 44. Right? So the total mass of carbon is 44. Right? Before I continue, let's say you have 2 persons, right? Person A and person B. Right? And someone says that they are going to give the parents of person A and person B a certain amount of money, right? Any amount of money that the parents receive, person A should get 50% and person B should also get 50%. That means if the parent got $1,000, then person A should get 50 and person B should get 50. If the parent got 100,000, each person should get 50,000, right? So when you have carbon dioxide, right, and you want the mass of carbon, there's a fixed percentage of carbon in carbon dioxide. So to know that, all you need to do is put the mass of carbon over the mass of carbon dioxide, right? So if you want to know how much carbon is present in a certain mass of carbon dioxide, 12 divided by 44, this right here tells you the percentage of carbon in 1 mole of carbon dioxide. So you can apply this to any mass of carbon. If you do 12, just a second. Alright, so 12 over 44 is 27%. So that means just like this would, person A would get 50% of whatever total you have. When you in the mass of carbon dioxide, 27% of it is due to carbon. So in this question, if I want the mass of carbon, all I have to say is 12 divided by 44, which is 27%, and multiply it by the given mass of carbon dioxide, which is 595, right? So this is the mass of carbon dioxide, right? But to know the mass of carbon in it, 12 over 44 times this will give you the mass of carbon. Remember, the 12 over the 44 gives you the amount of carbon in 1 mole of carbon dioxide, right? 12 over 44, that's 27%. So whatever mass of carbon dioxide you have, if you want carbon, find 27% of it. And the answer you should get is 0.162 gram. So that is the mass of CO2. That is the mass of carbon. We are going to do the same thing for hydrogen. Now if you look at the formula for water, it is H2O. So in water, you have 2 atoms of hydrogen. We know that the mass of hydrogen is 1. And you have 2 of them, so it would be 2. Now the mass of water, 16 plus the 2, that is 18. So just like with carbon, where 27% of any mass of carbon dioxide is carbon, it's the same thing. You have 2 atoms of hydrogen, so 2 over the 18, right? That would be like a percentage, which is, right, 0.111%. So you just apply this. So in any combustion analysis question, if you want the mass of hydrogen, 2 over 18 times whatever mass you are given. In this case, it was 0.304. And the answer should be 0.0337. 0.0337 gram. Right? So we have the mass of carbon and we have the mass of hydrogen. Now to get the mass of oxygen, you will add up the mass of carbon and hydrogen and subtract it from the mass of the sample. So the mass of oxygen would be equal to 0.25 gram, right, which is the mass of this sample, minus 0.162 plus 0.0337, right? And the answer you should get is 0.054 grams, right? So now we have the mass of carbon, hydrogen and oxygen. Now we can proceed to the part where we actually work out the empirical formula. So the first thing we had to do was get the mass of carbon, hydrogen, and oxygen. So now the mass of carbon is 0.162, the mass of hydrogen is 0.0337, and the mass of oxygen is 0.054. So the first thing we're going to do here is calculate the moles. Now remember, to get the mole is the mass of the compound divided by the mass of the element divided by the molar mass. So hydrogen is 1, carbon is 12, oxygen is 16. When you do that, you should get, for carbon, 0.0135. For hydrogen, it would be the same thing. And for oxygen, 0.00338. Alright? So once you calculate the moles, so here, so the first step in the empirical formula is to calculate the moles. So this right here, this is the mole. Then now we are going to divide each mole, compare the three answers, divide by the smallest number, which in this case is the 0.0038. And the answer you should get is 4 carbons, 10 hydrogen, and 1 oxygen. So the empirical formula is C4H10O. Alright, so let's put it here. So C4H10O. That is your empirical formula, right? Now we're going to, in order to calculate the molecular formula, we need to get the molar mass of the compound, right? So I'm going to erase this and we get to that part of the question. Alright, so this part of the question, we're going to use the universal gas law to calculate the molar mass of the compound. So we know that it says PV is equal to nRT. We know that P is the pressure in pascals. So in the question it said 1 atmosphere, that is equal to 101,000 pascals. We know R is the gas constant, which is 8.31, and T is the temperature in Kelvin. So 200 degrees Celsius, whatever the temperature is in degrees Celsius, we add 273 to it. So the new temperature is 473 Kelvin. The new pressure, instead of 1 atmosphere, it's 101,000 pascals. The volume must be in meter cube, right? So 131 cm cube, you will divide it by a million, you get 0.000131. So basically divide by times 10 to the 6. Alright? So right here, N is the moles, right? And we know that to get the mole, it is mass divided by the molar mass of the compound. So we have PV equal nRT. The N could be replaced in the formula with mass divided by molar mass. So that is what we are going to do. So instead of PV equal nRT, we have N, we are going to put mass divided by molar mass, because N is the moles, right? And we know mole is mass over molar mass. So PV is equal to, I'm just going to put 1 m for the mass, So it's mass over molar mass. Alright? And up top we would still have RT. Alright? So it's basically MRT divided by the molar mass. Now what we are trying to calculate is the molar mass. So we would need to transpose. So MRT is equal to PV times the molar mass. Now what we want is the molar mass, so we need to get rid of PV. PV cancels PV. Alright, I bring it over here. So the molar mass is MRT divided by PV. So let's work that out. So MRT, the mass, remember the mass of the compound. Alright, so the molar mass, the mass of the compound was 0.25 gram. R is 8.31. And the temperature now is 473 Kelvin. Divide that by PV, the pressure is in Pascal is 101,000. Right? And the volume is 0.000131 meter cube. Right? So this is the calculation for the molar mass. And you should get, let me see, you should get 982.66 divided by 13.23. You should get 74 as your answer. So the molar mass of the compound is 74. So that is how you would do it. Typically, the question would give you the molar mass of the compound. So this is not a typical combustion analysis question. They would have just go ahead and state that the molar mass of the compound is 74. So once you have calculated the empirical formula, you would have just gone straight ahead to calculate the molecular formula. So I'm going to erase this now, and we're going to calculate the molecular formula of the compound. So this is the molar mass of the compound. We're going to calculate the molecular formula of the compound. So to get the molecular formula of the compound, you would first need to find N. And N in this case is the molar mass of the compound divided by the empirical formula mass. Alright? The molar mass of the compound, as we just calculated, it was 74. The empirical formula was C4H10O. 12 times 4, 12 carbons, so 12 fours. Put the number of atoms first. So 4 atoms of carbon, a mass of 12. 10 atoms of hydrogen with a mass of 1. And 1 atom of oxygen with a mass of 16. So 12 fours, that's 48. Plus 10, that's 58. And 16, that would leave you with 74 grams per mole. So in this case, the empirical formula and the molar mass of the compound and the mass of the empirical formula is the same. Alright, so N is equal to 74 divided by 74, which is equal to 1. Now, to get the molecular formula, you would write your empirical formula C4H10O and multiply it by whatever n is. So in this case, n is 1. That means the empirical formula and the molecular formula is the same, because 4 carbons times 1, that is still 4. 10 times 1, that is still 10. And 1 times 1, that is still 1. Let's say the molecular formula of the compound, 70 and 70, that's 140. Let's say it was 148. You would have gotten n, which is equal to 2. Right? And this time you would have multiplied it by 2. So you would have gotten C8 H20 O2. Alright? So to get the molecular formula, just divide the molecular mass of the compound by the empirical formula mass. Right? But in this case, let me just erase that. It was actually 74 for both of them. So n is equal to 1. And so because n is 1, your empirical formula and your molecular formula is the same, which is C4H10O. Right? I will do some more of these questions in the next video, but that's it for this video. If you have any question, you can ask. Right?